Rolls-Royce has received $6 million in funding to develop its ambitious space nuclear reactor, which will be installed on the moon. A robotic exoskeleton with artificial intelligence enabled a paraplegic athlete to carry the Olympic torch. Scientists have developed a smart fabric inspired by tattoos that can become rigid or soft as needed. Advanced laser weapons have become more compact, and one of them has been installed on a British Army armored vehicle. For the first time in the world, electric boats are self-recharging directly at sea. These and other innovations and new technologies will be featured in this episode. Stay with me until the end to see all of this in today's video. Let's go! Soft and rigid materials have specific uses, but rarely do these two properties coexist in the same substance. RoboFabric, an innovation developed by scientists at Nanyang Technological University in Singapore, is a notable exception. Inspired by the protective scales of armadillos and pangolins, RoboFabric can switch between soft and rigid states, providing unique versatility. RoboFabric is composed of a network of interlinked 3D-printed polymer tiles connected by metal wires. When the wires are loose, the tiles can move freely, making the material soft. By tightening the wires, the tiles lock together, making the material 350 times more rigid. This feature allows the material to be used in various applications, such as arm casts that remain soft during positioning and harden to provide support. The technology has been tested in several applications, including a robotic gripper mounted on a drone capable of picking up and releasing items by switching between rigid and soft states, and a swimming robot that hardens and softens to move through water. These devices were customized through 3D scans of volunteers' limbs and printed in less than an hour, although the manual process of threading the wires still takes time, which is expected to be automated in the future. Laboratory tests showed that using RoboFabric in lifting supports reduced volunteers' muscle activity by up to 40%, highlighting its potential to revolutionize healthcare and rehabilitation. The implications of this technology are vast, promising applications in industrial and technological fields as well, offering new solutions for mobility and assistance. Let's start by exploring this incredible technological advancement that is capturing global attention. For the first time in history, an athlete using a robotic exoskeleton carried the Olympic torch. Kevin Piet, a French para-athlete, made this remarkable journey in front of the Temple of Hera in ancient Olympia, Greece, last Tuesday. About 11 years ago, an accident left the French tennis star paraplegic, but that did not stop him from returning to the sport as a para-athlete. Now, a video of him carrying the Olympic torch with the help of a robotic exoskeleton is going viral, amassing millions of views on social media. Piet is seen using the robotic exoskeleton while walking with the torch. He is not just a user, but also one of the first testers who helped improve this technology. He participated in specific competitions where people with disabilities use assistive technologies to perform everyday activities. Currently, these exoskeletons are primarily used for rehabilitation, but a customized version is being developed to provide greater independence at home. Piet has become the exoskeleton pilot for Wondercraft, a company that started in Paris and now has its headquarters in New York. The startup is known for developing the world's first self-stabilizing exoskeleton for walking. The personal exoskeleton was designed to help people with mobility impairments stand up and walk again. This exoskeleton was conceived to provide a new mobility solution, addressing the complex long-term physical and mental needs of these users, offering them greater freedom. Based on revolutionary engineering and robotics innovations integrated into Wondercraft's Atlanti X model, it mimics human walking, allowing multi-directional movement without using the hands. It is currently used in rehabilitation hospitals and walking centers in the United States, Europe, and also in Brazil. The Atlanti X utilizes its innovative self-balancing feature to enable multitasking, performing lower limb exercises, posture, balance, and upper limb strengthening safely. According to Wondercraft, the goal is a future where people with mobility impairments have new options to significantly improve their independence, inclusion, and health. Robotic engineering represents an important milestone that offers us a glimpse into the future of mobility. In a significant advance for the future of energy weapons, the UK conducted an innovative test with a laser weapon mounted on an electric armored vehicle of the British Army as part of the LDW program. Since their invention in the 1960s, lasers have been seen as revolutionary for armaments due to their ability to cut steel, travel at the speed of light, hit multiple targets instantly, and possess almost infinite and low-cost ammunition. However, Making lasers practical on the battlefield has always been a challenge. To be effective, laser weapons need to be powerful, maintain focus long enough, adjust the beam to handle atmospheric distortions, and be portable, robust, and compact. Advances in solid-state lasers and beam combiners, which merge multiple lasers into a single coherent beam, are making this technology more viable. The current challenge is to integrate these weapons into conventional military platforms. Recently, the British Ministry of Defence, in collaboration with Raytheon UK, conducted tests at the DSTL shooting range in Porton Down. Raytheon's system, mounted on a Wolfhound vehicle, was used to hit flying targets up to 1,000 meters away. Versatile, it can be installed on various platforms and operates with a command and control pattern, integrating with conventional radar and battle surveillance systems. Raytheon revealed that the equipment is already approved for combat use by the U.S. Armed Forces, designed to defeat drones, similar to NATO Class 1. The next step of the LDW program is to familiarize Army units with this new technology to discover how to best use it in combat. With the success of the first firing of a laser weapon integrated into a ground vehicle in the UK, DSTL demonstrated that the high-energy laser weapon system is capable of tracking, engaging, and defeating targets while mounted on a vehicle, proving that the technology is ready for the battlefield. Looking to the future, it is not hard to imagine whether we will see lightsabers, phasers, and blasters like those in Star Wars and Star Trek. Although it may seem like a science fiction idea, the evolution of these technologies raises questions about their potential impact and the dangers they may pose to humanity. Rolls-Royce has received an additional $6.2 million in funding from the UK Space Agency to develop a nuclear microreactor that could power lunar bases and propel spacecraft. This project, reminiscent of the 1969 science fiction film Journey to the Far Side of the Sun, is becoming a reality. With a total funding of $11.7 million, Rolls-Royce, in collaboration with the universities of Oxford and Bangor, plans to complete the project in 18 months. The first orbital test of the reactor is scheduled before the end of the decade, with a lunar version being tested a few years later. The goal is to create a dense, reliable, and portable power source for space missions and commercial applications. The microreactor will be much smaller, more aerodynamic, and portable than a small modular reactor, SMR. While an SMR generates 0.5 GW of power and occupies the space of 2 football fields, the microreactor will produce between 1 and 10 MW and will be small enough to be transported on the back of a truck. It can be used in planetary bases, moved as needed, and even continuously power rovers. The microreactor will be fueled by enriched uranium or plutonium pellets, as well as carbon and ceramic, arranged in a graphite core that regulates the nuclear reaction and conducts heat. Custom heat exchangers make the reactor lightweight and efficient at converting heat into useful energy. This energy will have numerous applications, including bases on the Moon or Mars, space stations, exploration vehicles, and nuclear propulsion systems. The tallest autonomous robot in the world, standing at 13 meters, operates in a warehouse to scan pallets. Equipped with advanced sensors, it can accurately identify temperature, humidity, noise, and light, effortlessly scanning over 300 square meters. Its technology allows it to use more than 12 high-definition cameras for a detailed environmental analysis. It is estimated that over 4 million robots will be operating in 50,000 warehouses by 2025, driving automation to meet the demands of e-commerce and address labor shortages in some countries. Developed by Dex-Roy, the robot is fully autonomous, recharging itself and scanning over 100,000 pallets every 24 hours. This efficiency increases operational speed and ensures meticulous inventory management. A highlight is its ability to create a real-time digital twin of the warehouse, providing insights into stock movement, storage conditions, and operational efficiency. Dex-Roy utilizes advanced technologies such as machine vision, simultaneous localization and mapping, SLAM, promising to revolutionize warehouse operations. The robot's control system integrates mapping, localization, path planning, navigation, and relocalization processes, enabling efficient simultaneous operations. As a result, the robot navigates autonomously through the warehouse, adjusting its tower to the required height, scanning aisles, and returning to its dock, all while avoiding obstacles. This allows it to seamlessly integrate into any warehouse environment, regardless of size or type of inventory. A new gene therapy for muscular dystrophy is bringing significant hope. It promises not only to slow the progression of the disease, but also to reverse the muscle damage already caused. The best part is that human trials are expected to begin in 2 years. Duchenne muscular dystrophy, DMD, is a genetic disease that prevents the production of dystrophin, a protein essential for muscle strength and integrity. Children with DMD start to have mobility problems at the age of 3 or 4, lose the ability to walk during their teenage years, and rarely survive beyond their 20s. As a genetic disease, DMD is ideal for gene therapy, but the large size of the dystrophin gene made it difficult to insert into cells. Scientists at the University of Washington developed a clever solution by fragmenting the dystrophin gene and loading it into a series of viral vectors, with instructions for muscle cells to reassemble the protein. In tests with mice, dystrophin production resumed in large quantities, with significant physiological corrections. The disease's progression was halted, and in some cases, muscle loss was reversed. Previous studies attempted to create smaller versions of dystrophin with some success, especially in tests with dogs. But the new technique from the University of Washington showed more promising results and required less therapy, reducing potential side effects. Researchers are optimistic and believe that this technique can be applied to other genetic diseases caused by mutations in large genes, bringing new hope to thousands of families worldwide. In the Belgian North Sea, an innovation is revolutionizing the maintenance of wind farms. Maintenance vessels can now hook up to an automatic cable to recharge their batteries while working. This innovative system is the first of its kind, representing a major breakthrough for the importance of electric vessels. Implemented at the Nobel Wind Farm, operational since 2017, this system was deployed 47 kilometers off the coast and established among the turbines using cranes from the installation substation. The installation, which provides power for about 190,000 homes, successfully used the system to recharge an electric boat without interrupting the wind farm's operations. The process is fully automated, requiring no human intervention, thus increasing safety. The charging station can supply up to $2 million of power for crew transfer vessels, CTVs, and up to $8 million for service operation vehicles responsible for turbine maintenance. Developed by Park Wind in partnership with MJR, a UK-based offshore automation and power systems engineering company, the recharge module can also operate on conventional vessels, reducing dependence on diesel engines and carbon emissions. MJR is analyzing the results from the Nobel Wind deployment to develop the world's first commercial offshore charging station, set to launch in early 2025. This innovation marks a significant step towards the sustainability and efficiency of wind farm operations, highlighting humanity's ability to transform technology for a greener and cleaner future. Did you enjoy the video? If so, please subscribe to our channel. This helps us grow and gain more relevance on YouTube, allowing our content to reach more technology enthusiasts. On your screen, you can see 2 new video suggestions from our channel. Keep watching and thank you very much for following us.